Swayam Prabha. Digital India. Educated India.
Welcome friends, this is the 7th class on GPS surveying. Today I am going to talk on GPS positioning principles and methods. The method of working of GPS is very simple. In spite of that, the different types of GPS positionings are available and we do adopt in the field depending upon different factors like what is the accuracy requirement, what really we are going to do in the field, what type of objects detail we like to cover, etc. So we need to know GPS basic principle of working as well as the different methods that is available, which will be discussed in this class. This class we will talk on firstly principle of GPS positioning and followed by different GPS positioning methods. Now the methods are fundamentally may be divided into different categories, but in this course I had divided it on the basis of the number of receiver, based on the movement of the receiver and also based on how the data will be processed. Now what is the principle of working of GPS? The principle of working of GPS is equivalent to what we learned in our surveying course is resection. Now what is the method of resection? If in the method of resection we find that if we know the location of 3 objects, then from an unknown location, if we can observe this and have a line of observation, then the intersection of these 3 line of observation will provide us the location of the point on which this unknown position is. So in this way, from 3 known objects and its orientation, we can get the location of an unknown point. Now in case of GPS we also apply the same principle, but in GPS we apply the method in analytical way. So the basic principle of GPS positioning is analytical resection method. Now in case of GPS, where from we get the 3 objects as well as the direction of lines. Now in case of GPS, it is the satellites whose positions we know from. So, in case of GPS, let us say there are 4 satellites 1, 2, 3, 4 which is being observed from the surface of the earth, and this is the point location whose position we want to determine. So, at this point what we do, we place a GPS receiver. This receiver receives GPS signals from these satellites. Now, as the GPS signal reaches to the receiver from satellites, these signals contain navigational data and these data we may use to find out the location of the satellites. So, the satellite position gets known once the signal reaches receiver. Suppose the location of satellite 1 is x1, y1, z1, and also from the time of transmission of the signal from satellite to the receiver, the range between the satellite and the receiver at that instant of time is also known. So, ranges, that is the distance between the satellite and the receiver, also known once the signals gets received from the GPS satellites. Now, if x1, y1, z1 is the location of the satellite number 1 and x, y, z is the unknown position, now from distance equation we can write like this. So, similar to this, for satellite number 2 we can write in that way. For 3 satellites we can write 3 equations and we have 3 unknowns. Solving this we can find out we can get the unknown location x, y, z. Now, we know that in case of GPS it is not the 3 satellite signal, but signal should be available from at least 4 satellites. Now, the reason behind is that in satellites the clocks or atomic standards used are of atomic standard, and the time measurement devices that is used in our receiver is quartz clock. So, there lies a lot of discrepancy in measurement of time between the satellite system and the receiver system. But one thing is that for all the satellites beyond, because it is being received by the same receiver, the discrepancy in measurement of time will be identical for all the signals coming from all the satellites to the same receiver. So, you will have one more errors or unknowns that is associated with a particular receiver, that is called time error or time measurement error or del t. So, we need that is taken is another parameter of measurement. So, in case of GPS it is not the 3 but 4 parameters we need to measure, and so we need to have at least 4 satellites from which signal has to arrive at the receiver to determine the position, because time is the primary parameter to be measured. As we can see, in case of measurement of range, it is the measurement of time which is required. So, the first parameter we need to measure is the time, which is including this error in time. So, all these things will be involved anyway. So, and in case of GPS we say that it is at least 4 satellites. So, the more numbers of satellites, signals from more numbers of satellites, the better it will be. So, this is in short about the basic principle of positioning of GPS. Now, we will like to discuss on methods of GPS positioning. Now, we can see from our principle of GPS that to carry out GPS surveying we need to place our GPS receiver at any position from which for which we need to determine the position. So, GPS surveying basically consists of placing the GPS receiver. Now, depending upon the field condition, depending upon the objects to be delineated or positions of object, depending upon the type of object whose position has to be determined, depending upon the accuracy requirement, these methods vary. Again, these methods will vary how we place the receiver in the field. There are different methods are available for GPS positioning, and they may be classified into different categories, but in my I had considered all the methods under 3 categories. Now, first category I want to consider on the basis of numbers of receivers that has been used in positioning. Now, the second category I would like to consider as what is the way, means whether it is in a static condition or in movement, depending upon the type of movement of the receiver we can classify the positioning methods. And third, on time, where depending upon the processing time. Now, on the basis of number of receiver, there are basically 2 types. One is that if we make use of a single receiver, that is called single point positioning or point positioning, and the other type is called relative positioning, where we do use more than one, that means minimum 2 or it may be more than still 2. Then depending upon the movement, again there may be 2 types. One is called static positioning, where the receivers will be in static condition, and another is called kinematic condition, where at least one of the receivers should be in a movement condition. So, and then our static type of again may be of 3 types. one is called absolute static positioning of GPS receiver, then it is called static method of surveying, and the third one is called rapid static. And under kinematic there may be two types. One is called single kinematic, where a single receiver will be used and that will be in movement condition, and a relative kinematic where there will be at least two receivers, of which one will be in a static condition and other will be in a kinematic condition. And then under processing, again there may be two types. One is called post processing, that means in this method of surveying, the data that has been collected during surveying will be processed much after it has been collected, and the other one is called real time, that means data will be processed simultaneously during it will be collected. Again this post processing will be, there are three types of mass positioning, that is, one is called stop and go, where we will consecutively stop and take the reading and we will move forward to the next point. Another is called kinematic, and the kinematic on fly, KOF. So these are the three methods of surveying, and under real time there are two types depending upon what type of data it will be processed. One is called DGPS, differential positioning, another is called RTK, real time kinematic, and nowadays one special variety of RTK is also available, that is called RTN, real time networking. So this is in short the different types of positioning methods that is available nowadays. Now let me go one by one. That single point positioning method, where the single receiver is being used and the signal will come from as many satellites will be visible from this receiver, minimum should be 4, and now this single, you can see here, this is a single, also absolute, also single. So we can say that single receiver may be in a state of static condition, that is called absolute static surveying, and if the single receiver is in kinematic condition, then it is called autonomous GPS surveying. And most of us who are having our mobile with the GPS, generally we made use of our mobile for our navigation purpose, specifically in a city area or in an area where you do not know or to move around. So that is called autonomous positioning. Now this absolute, again you can see that maybe in a static, means this is being used for very precise positioning, specifically for control point establishment we go for this. So this single is also coming here and also coming here, this is called absolute positioning for control point establishment, and this is for navigation purpose. Next, relative positioning. Here also we can see that relative here, in fact this relative positioning is widely prevalent among this, all these, mostly this is, then all these are relative positioning. Now what is relative positioning? In case of relative positioning, there will be at least two receivers, of which one will be on a reference station, means a station point whose location is known. This is also called control point, and other receiver who will be placed at point whose position is to be determined, that is called rover stations or rover point, and the receiver is called rover receiver. So the condition is that the both reference and rover receivers should receive signals from 4 identical satellites, at least from 4 identical satellites. This is the condition which is to be prevailed for relative positioning, and the epoch of observation for the rover receiver should be equal to that of reference receiver or more than it. That means epoch means, what is epoch? Epoch means interval, time interval in which the signal will be received. So for reference, suppose the epoch is 1 second or 1 second suppose, then the epoch of rover should be at least, means should be 1 second or more, that means 2 seconds, 3 seconds, etc. Now suppose the epoch of reference is suppose 5 seconds, then the epoch of rover should be at least 5 seconds or more, that means 10 seconds or something like that. It cannot be less than 5 seconds. So that is what is called epoch of the rover receiver should be less, equal to or more than what we have for the reference receiver. This is a very important consideration. First important consideration is that both reference and rover receiver should receive signals from at least 4 identical satellites. Second condition important is that the epoch of observation of the reference receiver should be less or equal to what it is available for rover receiver. Now after making the observation in a relative mode, we do process the data from both reference as well as receiver together, and during, as we do process the data together, there is every possibility that the error in observation in the reference receiver and the error in observation in the rover receiver will be more or less identical. So when we do process together, then identical errors will cancel each other, and that will lead us to better positional accuracy. That is what is the idea behind relative positioning. And so for any accurate GPS surveying, always we go for relative positioning, and relative positioning is widely prevalent among all the methods, as I have told you. So it is to be understood nicely. Next, let us take into moment consideration. As I told you that receiver may be in a static condition when it is not moving, and kinematic condition when it is moving, and again static condition, it may be absolute. That means if we take a single receiver in a static condition and taking observation, that is called absolute positioning, and that is used when there is no reference available around and when we have to start our work without having any known position. And in this case we need to take observation for a long duration, as well as you should take the epoch of observation high, like 15 second, 30 second, like that. Next, our relative static position, there is called relative static method. As I told you, in relative method means there will be two or more of this, one will be, at least one will be reference and one second will be second or third, fourth, all will be rover, and because it is static, so all these receivers will be in a static condition over the point over which we have to, for which we are in need to take the position and later we will download the data from both the receivers, all the receivers, and we will process together, and the position of the reference receiver is known. With respect to that, other location of other receivers will be determined, and for very accurate positioning we go for this, but in that case we should make use of precise ephemerides. Now precise ephemerides, what is ephemerides? Is nothing but navigational data. Precise ephemerides means precise navigational data which will be available in the internet site after defined, suppose 3 days or 7 days or 15 days. So if I take the precise ephemerides after 15 days, then that is the most accurate ephemerides or navigational data about the satellites, and if we make use of that to the relative static positioning, then that will lead us to most accurate positioning. And this type of method, this is method is used for establishment of best control points or when the baseline length are very high. So for long baseline length or for very precise control point positioning, we do go for relative positioning, relative static position for precise control points and long baselines. Now if the control points are of less important, means less accurate control point is to be established, or the baseline lengths are not that high, means less than 10 kilometer or 20 kilometer, if the baseline length is less than 20 kilometer, then instead of relative static positioning we go for rapid static positioning. Now rapid static positioning is same as relative static positioning, only thing is that in case of rapid static method we do take observation for smaller duration as well as our epoch interval also more. So and sometimes we may make use of lower quality of GPS receiver. So it is the receiver quality. Receiver quality means, that means quality of the data, then your time of observation, duration of observation, then epoch interval. These are the important considerations about the accuracy to be achieved, and then ephemerides used for processing, then processing software. So these are the things which need to be considered for to arrive at more accurate GPS positioning. So with this, static is over. Now kinematic condition. Now let us go to the kinematic method of GPS surveying. As I told you, in this case at least one of the receiver will be in a movement condition, and already I have discussed about the single receiver kinematic positioning. Now in case of relative kinematic positioning, one of the receiver will be in a reference station in a static condition, and the other will be or more than one may be work as a rover and will be in a kinematic condition. Now which is important is that actually this is the method which we will again see available with these methods. So we will discuss under the post processing methods. Now depending upon the processing time, when we process the GPS data either immediately after the collection of the data or afterwards, that on the basis of that we do classify into post processing. In post processing, GPS data is get processed well after it's get collected, and this is the method which is generally used for most accurate purpose. As I told you that relative static position, that is also post processing type, and relative kinematic is post processing relative kinematic, that means is stop and go kinematic and kinematic on fly. Now in this case stop and let us discuss with the stop and go. In stop and go method of GPS surveying, we need to place the reference on in a static manner, and then the kinematic one first we should place at any point. It may be any point, but only thing is that it should be within 2 kilometer from the reference station, so that both of them have the signal from at least 4 identical satellites, preferably it should be 5 and more, and then for few minutes, that means maybe 5 to 15 minutes depending upon the strength of the project, nature of the project, they should take signal from identical satellites having at least 5 identical satellites. That is, this process is known as initialization. Once it is being done, then the receiver, rover receiver is kept points of whose position is need to be determined. Now what we will do after initialization, the receiver has to be kept on the first point. Once it is taken to that point, then we will make it placed on the point and data has to be collected, and once the data collection is over, then it will be made in a stop, and then we have to take it to second position, that is stop and go. Go means it will be removing from one to other, and stop, during stopping process it will take the observation at the station. Now the most important thing to be noted is that in this process we have to do the initialization process. Second point is that during whole of this surveying, at least 4 or preferably 5 or more satellites should be identical in nature for both the receiver. That means signals from 5 or more satellites, identical satellites should come in both reference and rover receiver, and the epoch of observation of reference should be equal to or less than the rover receiver. And in case during this observation there is any loss of lock between the satellites, that means some common satellites are not coming, that means if there are less than 4 satellites which are not coming, then we have to reinitialize the process. So, and this method of surveying is to be done when we are need to capture data from point objects which will be coming repeatedly in any area of survey. Then in kinematic survey actually it is the same as, that means here also we have to do the reinitialization process as we did in stop and go method, but here after initialization the receiver will be in continuous kinematic mode. And generally for linear type of objects like the corner of the roads or seashore, like that we can go for kinematic surveying. Then the third one is that kinematic on the fly, in which no initialization will be done. Once you will start, the rover will start moving in a kinematic condition, like this type of method is applied for hydrographic surveying. So kinematic on fly hydrographic surveying, this is for linear objects, this is for a point object, line object or linear object, and this is for hydrographic survey. Another variety which is now popular very much is the real time GPS surveying. Now in case of real time surveying, the errors are sent from reference to rover, and rover makes corrections in real time and provides position in real time. Now so in this case there is an additional arrangement that is required to have. You can see here that there is a reference receiver which is placed on a point whose position is known, and this is the rover receiver, and this is a radio communication and it is connected with the reference receiver. So the basic idea is that the errors that will be available in this will be also available same as this rover receiver. Now as the point is unknown, so as the signals are coming, it will compute the position of this and already known position and computed position, that is the difference is the error, that error and some other parameters, this radio communication it will be communicated to the rover, and it is assumed that the error that is available with the reference position is also will be same as that of rover, and the rover will compute its position and make this correction and give the position in real time. So this is the fundamentals, and depending upon the errors, this error may be computed from code or from carrier. If the error measurement error message is computed from code, then it is called DGPS, differential GPS, and if the error message is being prepared from carrier phase, then it is called real time kinematic. Now so as you can see from this that the real time kinematic will provide us more accurate position, because these error messages are computed from the carrier phase of the signal, and still more accurate method has come up, that is called real time network. In this case what happens, there are more than one reference station, there will be a network of reference stations, and from this reference station there will be a central server where this signal will be coming and error message will be produced there, and the rover position is there, it will also provide its position data and all these things for correction, and all this information will go to the central server, and central server will process all the data and it will provide the real time correction message to the rover position. So this is called real time kinematic in network mode. So and this is the provides the best or most accurate real time positioning. So with this I like to conclude today's class. However, before concluding let me summarize that it is the analytical dissection method which is being basics or which is the behind GPS positioning. For GPS positioning we need at least 4 satellites and preferably 5, and based on different criteria there are different methods that is available nowadays. Of this the single autonomous kinematic mode is for our reconnaissance survey. For reconnaissance survey, we can go for autonomous positioning method. For to establish our control point, we should go for relative static method, and if we want to set up long baseline, also we will go for relative static method. But if we want to establish lower order control point or smaller baseline, we will go for rapid static method. If we want to go for positioning of point objects, then we should go for stop and go method. If we want to go for line objects like the road or railway line, we should go for kinematic method. And for land surveying work, it is always advisable to go for post processing mode of GPS surveying, and if we want to end up with a very accurate, we should go for post processing GPS surveying method along with precise ephemerides. Thank you very much. See you again in the next class. Next class will be on demonstration of some of these methods that will be done in the field. Thank you.